Okay, we're looking at problem 3 from lesson 4-5. It says writing a nonlinear function rule. It says write a function rule for the area of a rectangle whose length is 4 feet more than its width. What is the area of a rectangle when its width is 9 feet? So there's two parts to this question. Step 1, represent the general relationship first. The area of a rectangle is the product of its length and its width. So they drew out a visual. I usually draw out a visual. It helps me out also. Length times width equals my area. It says revise the model to show that the length is 5 more than the width. So the width is 5 more than the length. So this is the length here. Length equals the width plus 5. That makes sense. Then it says use the diagram in step 2 to write a function rule. The function rule would be w plus 5 times w. Or if we multiply everything out by using distributive property, we get w squared plus 5w. Represent the rectangle's area. Substitute. Now we're going to do the second part. It says what's the area of the rectangle when the width is 9 feet. We're going to substitute in 9 for w, and we get 126. All right, so now let's do it on our own. So it says write a function rule for the area of a triangle whose height is 4 inches more than twice the length of its base. What is the area of the triangle when the length of its base is 16 inches? So let's draw it out. Oops, forgot to clear. Excuse me. All right, so we have a triangle here, and the triangle has a base and a height, right? That's what triangles have. And the area, sorry about that, is equal to 1/2 height times base. Okay. Oops. Trying to read more of the problem. Let me see if I can get it. All right. So it says, write a function rule for the area of a triangle whose height is 4 inches more than twice the length of its base. Okay, so my new height, and I can't just do it like they do, I have to write it out like this. So my new height will be 4 inches more, so that means adding. I probably need to put the inches there, excuse me. Plus 2 times the base, twice the length of its base, right? So that's my new height. So when I put it back into my new formula, this is what I really have. I have height equals 4 inches plus 2b. And so now I can plug this into my formula to get my new function. So I have area equals 1/2 times my height, which is, I'm going to change this around to 2b, and I'm going to leave off the inches. We know it's inches, just to make it so not so confusing, times b. So now I have to use distributive property. I'm going to go ahead and multiply this 1/2 through first, and I get b, because 1/2 of 2 is 1, plus 2, still all times b, distribute that b through, and I get b squared plus 2b. So there's my new function for the area of this new triangle, b squared plus 2b. All right, so let's look at the second part. It says graph the function rule for problem 3. How do you know it's nonlinear? Well, before I even graph it, I know it's not nonlinear because I have this squared here, right? So if I change this to y and this to x, so this is what I'm going to graph. I have y equals w squared plus 5w. I'm going to change this to y equals x squared plus 5x. Just for my calculator's sake, because I'm going to use my free graphing calculator at www.desmos.com. And I'm going to say y equals x squared plus 5x. And so I knew it was going to be quadratic because of the square here. I hope that this helps.